Welcome, Calculus AB. This is lesson 4.1, absolute extrema and the mean value theorem. Let's begin. So take a look at this function right here. What are the maximum and minimum y values, or where are they at? Let's just ask that question. So the maximum is going to be the highest one. The max is going to happen right here, so that max, because that's like the highest y value. Now the minimum is going to happen right over here. So sometimes in a function, I want to find out where like the maximum y value and the minimum y value are. And if I look at the graph, those would be two cases, right? Maxes, generally you want to check like the tops of like a hill like this. Or you got to check out like kind of like bottom parts here. Maybe you got to check this, but like on, oh no, this is lower. And this isn't as high as this one. So you got to like look at some parts, right? Well, we have some definitions for these two things. One of them is called the absolute maximum and the absolute minimum. So you might like talk about a function or the whole function or just part of the function, like from some value A to some value B, like a certain domain. We might want to find out what max and min. So the absolute maximum is called the greatest y value of a function, and the minimum is the smallest y value. So let's take this example. If this was at this point, corresponding y value is -6, and this point right here, the corresponding y value was like 7. My absolute maximum in this case would be 7, and my minimum in this case would be -6. So that's kind of what it looks like. Now, what if I change this function slightly, and it just kept going like this? Well, now my absolute maximum is no longer 7. Let's say it's 8. And so now it's no longer 7, it's 8. So you got to check a few things when you're looking for absolute max and min. See, like, kind of got these hills going on here. That's absolute max and min. But you might notice some other properties, like, what is this here? Is that important? I know it's like a bottom right here, but it's not the bottom of the whole function. And sometimes we actually care what those are too, and we call those relative maximums and minimums. So I'm going to create a function right here. This one, I'm going to modify this, just like I did before. Say it goes up to here. So relative max is the greatest of y value of nearby y values, like in a relative area. And relative max, oh, this should say relative minimum. Did I do that on the last slide too? No. Minimum is the smallest of the nearby y values. So it's kind of like in a relative area. So if I'm looking at this graph, you know, this is now the maximum, right? That's the absolute max. But right here, we have a maximum just of this area. It's the vertex, right? So we're going to call this a relative max. And I know this is the absolute minimum, but here's like also a minimum. So we're going to call this a relative minimum. So that's what it looks like in that graph. Now, I'm going to draw another picture. You couldn't have more than one. What if you have a graph that does this? Look at that. So how many relative maxes do I have? I got 1, 2. So in this case, I have 2 relative maxes. And how many relative mins? Well, I got 1 and 2. 2 relative mins. So I can have multiple. Now, what about these endpoints here? Are those relative maxes and mins? No. Endpoints don't count. So we only look in between the function where relative max and mins are. Oh, you might also ask another question. I'm going to reset this. So what if I had a function like this? This is a relative max, and it's also the absolute max, so you can be both. Right here, it's relative and absolute. All right, we have this other concept of critical numbers. So this is a big thing of this chapter. So you see we have those relative mins and maxes, right? Well, we talked about the relative min and max was the y value. The critical number is basically just the x value of that point. So it's where the official definition is where the function exists. But the derivative of that function is 0 or does not exist. And the derivative is like the slope. When you're at the absolute min or max, the slope is 0. So that's why this is some way we find critical numbers. We want to figure out where the slope is 0. And in these two cases, it's 0. Now, we also care about where it does not exist. You might be like, well, what is that going to look like? And here's an example of what this looks like. What if I did an absolute value function? That makes that V-shaped thing. So a derivative does not exist when you have sharp turns. So this could be a critical number. It's a relative min or max. So we don't, so we want to keep track of those. So this would be a case where the derivative does not exist. And we want to check those as well, or keep track of those as critical numbers. All right, let's break down all those definitions. So here's another thing. One note here, sometimes we say absolute max. You might see the word global maximum or minimum. Relative maximum, you might see local max or min. Sometimes you'll see the word extrema, which is the same thing as absolute max and min. So they all mean this. These kind of mean the same. Absolute, global, extrema are the same. Relative max and min being the same as local max and min. And critical numbers, just we went over. So remember, these are all y values. Well, all of this stuff, absolute max and mins, are y values. Critical numbers are x's. Everything else is the y value. Sometimes I'm asking for the point, so I might want the coordinates of the point of the relative max or min. But yeah, you're going to be looking for x values, but usually you want to find the y value ultimately. So how do you figure out the absolute max and minimum? We have to check a few things. And you need to check all the critical numbers and the endpoints. So we're going to try to find absolute max and min this lesson. So you got to check all the critical numbers and the endpoints. So you got to figure out where the endpoints are, if there are endpoints, usually there are, and then figure out the critical numbers. Again, critical numbers are when the f prime, the derivative, equals 0 or it does not exist. And here's the test for this. So you find all critical numbers, find the y values, and choose the biggest and smallest at y values. And some notes. Absolute extrema, which we're finding, can occur at critical numbers or endpoints. That's why we check both. And relative extrema are only critical numbers. So that means the endpoints won't be relative. All right? So let's do this example. So this is a picture. What is the absolute maximum of f? Well, if you're looking at that, that's the y value, and this is the highest y value, so it's 4. What x value does f have an absolute? At what x value does f have an absolute maximum? So we know it's 4, it's right here. What's the corresponding x value? -4. Now, if I wanted to write that, what's the point, absolute maximum point? I'm writing that as an ordered pair, -4, 4. So these are all asking about this point. It's just asking you different ways to represent what that is. The absolute minimum of f. So you're like, what's the slowest point? And you're like, here. But here's a problem. There's no point there. So what's the minimum? Like, it's almost -2, but -2 doesn't exist. So this is a weird case. So you say, is there -1.9999? No. We say it does not exist. I know that's weird. There's a point there, we'd say -2, but this does not exist. And at what x value does f have a relative minimum? Okay. Relative, remember, it's like in certain areas, you're looking like the valleys. So this would be a relative minimum. So at x equals -3, we actually have a relative minimum right here. This is kind of like one of those valleys. So we're going to say 1. And those are our 2 relative minimums. It's like, what's the smallest part of an area? All right. Where is the relative maximums? So, okay, it can't be endpoints. This would be a max, but it's no endpoints. And we kind of got a peak right here. So we're going to say x equals -1. And, okay, so here's the thing. You might say, oh, here's the top. So 2 at x equals 2. No, because there's no point there. So this doesn't count. That's weird, I know. So it's just 1. All right, so we're going to actually find the global extrema. I mean, it's absolute minimum, maximum. And this is just saying this is different ways to ask the same question. All 3 of these would be find the absolute min and max of this function. So going back to my steps, going back a few, I want to find the critical numbers. So first step, find critical numbers. So I have to find the derivative. So we're going to find critical numbers. I'm going to abbreviate that. So we have to find the derivative. So f prime of x. The derivative of this would be 1/3 times 3x squared minus 2 times 2x. So cleaning that up, these cancel. It's just x squared minus 4x. So you want to set that equal to 0 and does not exist. Now, this is polynomial function. It'll never does not exist. So set it equal to 0. I want to factor out an x. So you get x times x minus 4. And you're in factored form. So you can set each of those factors equal to 0. That means I have 2 critical numbers at x equals 0 and at x equals +4. So now I am going to check each critical number and each endpoint. My endpoints are right here, -1 and 3. So when I want to check, I want to check CNs and the endpoints. This is going to be step 2. So to check this, I like making a table, an XY table. And you want to list all your endpoints and all your critical numbers. So I'm going to go -1 to 3 for my endpoints. And then I got 0 and 4. Now, here's the thing. We're only talking about the interval from -1 to 3. So although 4 is a critical number, it is outside my domain, so we do not do 4. We're only doing -1, 0, and 3. You are going to find the y value, so that means plug it into the original equation, which is f of x. So plugging in a -1, I get 1/3 times -1 cubed minus 2 times -1 squared. -1 cubed is -1, so it's -1/3. And this will be minus 2. So -1/3 minus 2, and 2 is the same thing as -2 6/3. That'll be -7/3. When you plug in a 0, you get 1/3 times 0 cubed minus 2 times 0 squared. This is just 0. I'm going to circle the answers. Or square them. 1/3 times 3 cubed minus 2 times 3 squared. 3 cubed is 27, divided by 3 is going to be 9. Minus 9 times 2 is 18. So -9. Now that I've done that work, my absolute max, what is the absolute max? The biggest y value out of these 3 is going to be 0. My absolute minimum is going to be -7/3 is -2 1/3. So it's -9. That's how you do these. A little bit of work, I know, but need some practice. All right, so let's look at this one. It's an absolute value function on the interval from 0 to 5. So you got to kind of remember how absolute values work. You remember it's that sharp turn? On an absolute value function, the sharp turn, and that's where the derivative does not exist, is going to happen when inside the absolute value equals 0. So my first step is finding the critical numbers, is finding that derivative equal to 0 or doesn't exist. Well, can't really do a derivative of absolute value, but its derivative f prime of x does not exist. Where's that going to happen? When inside the absolute value is 0, that's when it does the sharp turn. That's going to happen at x equals 2. And now I got my 2 endpoints and I got my critical number, so we're going to check on a table x, y. 0 to 5, and 2 is in between. If you plug in a 0, you get absolute value of 0 minus 2, which is 2. Plug in a 2, absolute value 2 minus 2, which is 0, and absolute value 5 minus 2, which is 3. So my absolute maximum in this case is going to be 3. Absolute minimum in this case is going to be 0. All right. Oh, geez. This keeps going. You know what? I'm going to go over this in class.